Welcome to section 6.6, phase shift. So how to graph a sine curve or cosine curve with phase shift. Different textbooks will have different notation. Sometimes the coefficient here on x is b or omega, just depends. First you want to determine the amplitude, the absolute value of a, and the period, which is 2 pi divided by omega, or the coefficient on x. And then the phase shift. So I'll show you exactly how to do that. Basically, the phase shift will change if the period is changed. So we'll analyze that in some examples. Determine the starting point of one cycle of the graph, and then determine the ending point, and then divide it into 4 subintervals, so you find the step. Use the endpoints of the subintervals to find the 5 key points on the graph. Plot the 5 key points, and then connect them. And if b does not equal 0, then apply a vertical shift. But sometimes that b is referred to as something else, CED, whatever. It just really depends on the text. So I'll do a more generic breakdown. I won't use all the variables that are given here, depending on whatever author your teacher's using. So first example, find the amplitude, period, and phase shift of each function. Graph each function. Be sure to label key points. Show at least 2 periods. Okay. So first things first, the amplitude, that's going to be the absolute value of 3, which is 3. Now, the period is equal to 2 pi divided by the coefficient on x, which is 2. So the period is pi. The step is always the period divided by 4, so pi over 4. Now, in order to find the phase shift, we need to rewrite our function. So notice here we have y equals 3 cosine 2x plus pi. Now, if you're thinking back to transformations, remember, if you have some number added in quantity with the x, then that's going to be a horizontal shift. However, since the period is being affected, this shift isn't pi units to the left, but rather I need to factor out that 2 to see what the true phase shift is. So I have 3 cosine, factoring out a 2, now I'm left with x plus pi over 2. You can always double check that you factored that out correctly by just distributing in your head and making sure you get back the original equation. So what this means is the phase shift is equal to negative pi over 2. So we're going to shift to the left pi over 2 units. And if you go back to your notes from when we covered transformations of functions, this is consistent with exactly how we did that. Okay, so we're going to start at negative pi over 2, and then the step is pi over 4. So it makes sense here when we're determining how to scale our graph that I would let each tick mark represent pi over 4. So here's my x-axis, here's my y-axis. The amplitude is 3. Let's scale this by 2s. 1, 2, 3. And then down to negative 3 right here. So I'll call this pi over 4. Then this would be 2 pi over 4 pi over 2. This is negative pi over 4, negative pi over 2, and we can get started. So the phase shift is negative pi over 2. So that's where my first x value would be. Then the step is pi over 4. So I'm going to add pi over 4, then I'm at negative pi over 4, then 0, pi over 4, pi over 2. So that's 5 points right there. The problem asked for 2 complete cycles, 2 periods. So we can keep going. We would just need 4 more points. So adding another pi over 4 to pi over 2, that would be 3 pi over 4. Adding another pi over 4, we're at pi. 5 pi over 4. 3 pi over 2. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points. 9 points is 2 cycles. All right, and then now we're ready to graph. So cosine, remember, cosine starts at its max value. So since we've shifted negative pi over 2, that's basically where my new y-axis is. You could think of it as that's our starting point here at negative pi over 2. Then at pi over 4, negative pi over 4, we're back to 0. At 0, we go down to negative 3. At positive pi over 4, we're back to 0. Up to 3, back to 0. Down to negative 3, back to 0, and then back up to positive 3. So here's our graph. Make sure you draw it nice and wavy. And then at the end, make sure you show that arrow goes down. It doesn't go upwards. Let's list the domain and range. The domain is going to be all real numbers, negative infinity to infinity, and the range, well, the min value that the graph takes on is -3, and the largest value it takes on is +3. And I include both those points because the function actually equals 3 and -3. All right, not too bad for a first example. Let's move on to something a little more tricky. So, y equals -2 times sine of 2x minus pi over 2. Let's get that factoring out of the way first. So y equals -2 times sine of 2 times x minus. Now, if I'm factoring out a 2, think to yourself, you're dividing by 2, right? So then this is going to become pi over 4. You can just distribute again to double check. So amplitude, that's the absolute value of A, absolute value of -2, which is 2. We're also going to reflect over the x-axis because of that negative sign. The period is going to be 2 pi divided by 2, which is pi. So the step is going to be pi over 4. Now the phase shift is equal to positive pi over 4, since in this case I have x minus pi over 4. Remember, it's always the opposite, just like our horizontal translations of functions. And we're ready to graph. So we're going to start pi over 4 units to the right. Shift to the right. Okay, so that's our new starting point. And since the step is pi over 4 as well, we can have each little tick mark on our graph be pi over 4. I'll say this is 1, 2, -1, -2. So we're shifting pi over 4 to the right. So the first x value I'm going to label as pi over 4, and then the step is also pi over 4. So from here I'm going to add another pi over 4. 2 pi over 4 is pi over 2. Add another pi over 4, 3 pi over 4. Add another pi over 4, we're at pi, and 5 pi over 4. So that's one period. I have 5 points. I asked for 2 cycles. I can keep going this way, or why don't we go in the negative direction? So pi over 4, one to the left would be at 0. Another one would be at negative pi over 4. Then a negative pi over 2. Negative 3 pi over 4. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So 9 points is 2 cycles. Very nice. So now remember, my starting point is here at pi over 4. And our sine graph starts at 0, right? Sine of 0 is 0, so it starts right here at the middle line. And then one step to the right at pi over 2. Normally it would go up to 2, but remember, we're reflecting over the x-axis because of that negative. So I'm going to go down to -2 at pi over 2, then back to 0, then up to +2, and then back to 0. All right. Now let's keep going in the other direction. So at 0, we're going to go up to 2, then back to 0, down to -2, and back to 0. So here's our graph. This is the most fun part, right? After you did all the hard work, you get to draw a nice little curve. Okay, let's list the domain and range. It didn't ask for it, but it's good practice, and we like to be thorough. So the domain, well, that's always the same. Negative infinity to infinity, all real numbers. What about the range? The range is going to be from -2 to +2. All right, looks nice. Let's try another one. So y equals 2 cosine 2 pi x minus pi minus 1. All right, this one looks a little different, but just carry on like before. I'm going to factor out the coefficient on x. That way I can identify the phase shift. So y equals 2 times cosine of 2 pi times x minus. Remember, whatever you're factoring out, you could think of dividing by that. So if I'm factoring out 2 pi, I'm taking pi and dividing it by 2 pi. I'll do it off to the side. Pi divided by 2 pi. The pi's would cancel, and then this would give me 1/2. And then minus 1 goes outside of all those parentheses. If you don't trust yourself, taking a quiz or a test, you just distribute this back out and make sure you get the original function, okay? All right, so the amplitude is 2. The period, this time it's a little different. We take 2 pi and divide it by the coefficient on x, which is also 2 pi. So that means the period's just 1. It's not a multiple of pi anymore. The step is the period divided by 4, so 1/4. And the phase shift is equal to a positive 1/2. Remember, you take the opposite of the sign that you see there. So this is shifting to the right by 1/2. And also, don't forget, we have to shift down 1 unit. Okay, so let's start labeling our axes, and then I'll put little dash lines to help us make sure we keep track of that vertical shift and stretch. All right, here's the x-axis, here's the y-axis. As soon as I notice the step is 1/4, that's pretty much what I want to let each of those tick marks represent. So this is going to be 1/4, and then this is going to be 2/4, which is 1/2. And my phase shift starts right here, 1/2 to the right. And then the step is 1/4, so I'm just going to keep adding 1/4. So we'll get 3/4, 1, 5/4. Don't write 1 and 1/4, okay? It's always, I know they call them improper fractions. When you were in elementary school, you probably thought it was something not proper, but don't use mixed numbers. 5/4, 6/4, which is 3/2. 1, 2, 3, 4, 5. That's 5 that way. And then we can go the other way. So 1/4, 0, -1/4, -1/2, -3/4. So do I have 9 points? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I did 10. Oh, whatever. It's good practice. Okay, now we have a vertical shift down 1 unit. So let's label the y-axis. This is 1, 2, 3, -1, -2, -3. So what I like to do is just put in a little dashed line. That's going to be basically like our new x-axis, our new 0 line. And since the amplitude is 2, then I'm going to draw another dashed line 2 units up from there at +1, and 2 units down from there at -3. And I'm going to use that as a guide when I'm plotting my points. It'll be really helpful, so I recommend doing this. All right, now my phase shift is 1/2 to the right. I'm graphing cosine. So normally cosine starts up at the top, right, at its max value. So in this case, it's going to start at 1. Then at 3/4, we go to the 0. Well, my new 0 is down here at -1, the middle line. And then if you have these lines, you don't have to think so hard. So then when I go another step over at +1, you go down to the bottom line, back to the middle, up to the top. And then we just fill in the other way. Back to the middle, at the bottom, back to the middle, up to the top. That's 2 periods. We don't have to do -3/4, but why not? Looks good. So relaxing. Okay, don't forget the arrows. They're on the ends. And then let's list the domain and range. So the domain is from -infinity to infinity. Ooh. And what about the range? We'll use the graph to help you. So the smallest y value is going to be -3, and the largest is +1. All right, looks good. Couple more. Example D. Y equals 3 times tangent of 2x minus 1. Notice this -1 is not a phase shift. I actually threw this in here to see if you were paying attention. A phase shift involves the x coordinate, so it needs to be grouped with x. That would be a phase shift if the 2x minus 1 was all in parentheses. But that's not what we have going on here. So that -1 actually is a vertical shift down 1 unit. So actually this graph is one that we could have done in the previous section. But I know tangent can be tricky for people, so let's go ahead and practice. So we have a vertical stretch by 3 units. Remember, tangent, cosecant, and secant do not have an amplitude. They're unbounded. So amplitude is a term we only apply for sine and cosine graphs. The period, remember for tangent, you take pi divided by whatever coefficient there is on x. In this case, it's 2, so the period is pi over 2. That means the step is going to be the period divided by 4, or times 1/4, which is pi over 8. So there's our step. We have a vertical shift and a vertical stretch. All right, so let's go ahead and label our axes. Here's x, here's y. Since the step is pi eighths, maybe we'll let each tick mark represent pi eighths. So this is going to be pi eighths, 2 pi eighths, which is pi over 4. Then there's 0, negative pi eighths, and negative pi over 4. And remember, tangent goes through the origin, and then the asymptotes are split evenly on either side. So we're going to have an asymptote here at pi over 4, and then another one at negative pi over 4. And then let me label my y-axis. So we'll call this 1, 2, 3, 4, -1, -2, -3. Now remember, we shifted down 1 unit, so this is basically my new x-axis. And there's also a vertical stretch of 3 units. So up 3 from there is going to be at 2. And down 3 from there is going to be at -4. Maybe it's too many colors going on, but whatever. Okay, so at 0, we're going to start graphing at -1. And then a quarter of the way through pi eighths is normally at 1, but now we're going to go up to 2. And then at negative pi eighths, we're going to go down to -4. And then remember, tangent sort of looks like x cubed squished between those 2 asymptotes. So that's one period. If we want to draw another period, then we can just keep adding pi over 8 here. So pi over 4 is 2 pi over 8. I can keep adding the steps, so add another pi over 8, that's 3 pi over 8. Then 4 pi over 8, which is pi over 2. Then 5 pi over 8. And then 6 pi over 8, which is 3 pi over 4. So that's where my next vertical asymptote is going to go. And then halfway between at pi over 2, I'll plot the middle line at -1. At 5 pi over 8, we plotted at y equals 2. And then at 3 pi over 8, -4. And then connect everything. Don't forget your arrows. And that's it. All right, let's list the domain and range. Now the domain is going to be all the x values such that x does not equal everywhere I have a vertical asymptote, so all the restrictions. So the first vertical asymptote I see is at pi over 4 plus, and then how long does it take to repeat until I get another vertical asymptote? Well, the distance from pi over 4 to 3 pi over 4, that's 2 pi over 4, which is pi over 2. And it's no coincidence, that's also the period. So x cannot be pi over 4 plus pi over 2 times k, where k is an integer. Now what about the range? The range is way easier. It's just all real numbers, always. Okay? Good. Last one of the graphs, and then we'll finish with a relaxing problem. So y, oh my goodness, y equals 2 sine 3x minus pi over 2 plus 2. All right, so let's get the worst part over with first. Let's factor out that 3. So y equals 2 times sine of 3 times x minus. Now divide by 3, multiply by a third. This is going to become pi over 6 plus 2. Looks good. Let's box it. I'm proud of it, aren't you? Okay. Now, amplitude is absolute value of 2, so 2. The period is 2 pi divided by the coefficient on x, which is 3, so 2 pi over 3. the step is the period divided by 4. So 2 pi over 3 divided by 4, just think multiply by 1/4. So that's going to be pi over 6. And the phase shift is a positive pi over 6. So we're shifting to the right. Anything else you notice? We have a vertical shift up 2 units. Okay, looks good. I think we're ready to roll. So since the step is pi over 6, let's let each tick mark represent pi over 6. And my phase shift is pi over 6 to the right. So that's really convenient. So here's my new starting point, pi over 6 to the right. And then let's graph 2 periods. So I'm going to keep adding the step 4 times. So 2 pi over 6, that's going to be pi over 3. 3 pi over 6, that's pi over 2. 4 pi over 6, that's 2 pi over 3. And then 5 pi over 6. So that's 1 period. Now let's go the other way. So pi over 6 minus pi over 6, that's 0. Then negative pi over 6. Then you can actually just copy the values over. Did you notice that? Negative pi over 3 and negative pi over 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So that's 2 periods. Okay, since we have a vertical shift up 2 units, let's call this 2, 4, 6. I'm going to draw some dashed lines to help me. So we're shifting up 2 units. Here's my new x-axis. And then the amplitude's 2 units. So 2 units up from there will take me to positive 4. And then 2 units down from there is back to the x-axis. So the graph is going to live in between these dashed lines. All right. And we're graphing sine. So we're going to start at pi over 6. That's my phase shift. So sine starts in the middle. Sine's going to start here at 2, since we've shifted up 2 units. Then moving over 1 step to pi over 3, I'm going to plot up here at 4, back to 2, down to 0, back to 2. And then same pattern on the other side. 0, 0, back to 2, up to 4, back to 0. And here's our curve. I think this was my favorite one so far. Okay, let's list the domain and range. What's the domain? Yes, it's all real numbers, negative infinity to infinity. And how about the range? What's the smallest y value that you see? It's 0, and the largest is 4. Perfect. Looks good. Now, last example, we're going to go the other way. We're given some characteristics about a function, and we have to write its equation. Okay, so we have the amplitude is 3. They tell me to use a sine function, and the period is pi over 2. So now I want to know what's the coefficient on x, right? Sometimes we call it tau or b, so I'll use tau. So that's going to equal 2 pi over omega. Another way to think about it is when we find the period, we take 2 pi and we divide by the coefficient on x, right? We divide by that coefficient on x, which depending on your textbook can take on different names, but we'll call it here omega. Okay, so if I want to figure out what the coefficient on x is, omega times the period is equal to 2 pi. So omega equals 2 pi over the period. So 2 pi over 2 is going to give me 4. And then the phase shift is equal to 2, which means I'm going to have x minus 2, a 4 in front. This is a sine wave, and the amplitude is 3. See how I put everything together? And then for your final answer, you do want to distribute that 4 back out. So y equals 3 sine 4x minus 8. And we're done. So hopefully you like these ones, just writing the equation. They're not too bad. All right, that concludes section 6.6. Don't forget to comment, like, and subscribe, and feel free to leave me questions and further video requests down below.